Imagine this. You are traveling at 200 miles per hour on a train. That's a very high speed. You are relaxed, scrolling through your phone, or reading a book. You trust the doors will open safely. You trust two trains will never be on the same track at the same time. You trust that there won't be a collision. You trust so much. But that trust rests on something invisible. Guess what? It is called software. You are trusting the software that governs every movement of that train. And that software is built by humans. Systems that can make mistakes and introduce what is called bugs. If your social media apps fails to load because of a bug, it is annoying, you refresh it and you simply move on. But if railway control software fails, there can be casualties. There is no refresh button. It is a safety critical system. Now, here's the real question. How do we build software with no mistake? With no room for failure? Well, you might think that the answer is simple. Just test it. But that's not so. In safety critical system, we do something unusual. We do not just test the system, we prove it. And that is called formal verification. You know what? Testing is just like checking 1,000 journeys for failure. If nothing goes wrong, it feels reassuring, but it guarantees nothing about the next journey. The failure could be hidden in the 1,001st journey. Instead, formal verification proves that a collision or failure is logically impossible. It guarantees it. We do this by translating software into logic. We express safety as logical properties. It is just like saying the traffic light is green. Then the junction must be clear. Once I know that the junction is not clear, I can logically conclude that the traffic light must not be green. That is simply logic. So for a train, every signal, every sensor reading, every emergency braking command, all are constrained by mathematical guarantees. Modern trains, aircrafts, medical devices, and autonomous cars are controlled by millions of lines of code. As automation increases, so does complexity. Complexity without proof is trick. So the next time you stand on a platform and you feel the vibration of an approaching train, remember this. Long before that train ever moves, someone asks not, does it seem safe? But can it ever fail? And somewhere in lines of logic you will never see, the question gets answered. Thank you.